In examples 3 and 4, we're dealing with cases or situations involving projectiles being launched. In example 3, a firework rocket is shot upward at a rate of 605 feet per second. We want to use the projectile formula that's given to us to determine when the height of the firework will reach 4,589 feet. More specifically, when will it first reach that height? So what we have is a firework that's being shot straight up in the air with an initial velocity of 605 feet per second. And the question is, when will it reach a height of 4,589 feet? In this formula, we have 3 different letters. We know we want to substitute in for h. H is the total height, which we're interested in that being 4,589. T is the time it takes to reach that, but that's our unknown. And then we have V0, V0, which is the initial velocity, and that's given to us as 605 feet per second. That means we want to set up and solve the equation 4,589 equals -16. T is still this missing piece of information that we don't know what it is. -16t squared plus 605 times t. We'll do that using Symbolab. And we end up with 2 different values. In this case, both of these values could make practical sense. We have about 10.5 and 27.3. They're both positive values, but we need to think about what those values mean to understand which answer is the correct solution. We were asked in the problem, when will the rocket first reach this height of 4,589 feet? That'll happen after 10.5 seconds, that earlier value. The rocket will continue shooting up into the sky, but eventually has to drop back down. It will hit that same height a second time. That's what the 27.3 represents. Since we want just that initial height, then we would say that t is approximately 10.5 seconds. So after 10.5 seconds, that firework will first reach that intended height. In example 4, we're told that a stone is dropped from a 190-foot platform. We want to use the formula that we're given below to determine how many seconds it will take for the stone to hit the ground. So if we have our ground level, then we have some platform that's 190 feet in the air, and a stone that's being dropped straight down until it hits the ground. What we want to do is determine what values we should plug into this equation and what it is we're trying to solve for. H is the final height after our experiment has concluded, which in this case will be 0 because we're wondering how long it will take this object to hit the ground. Ground level is h equals 0. T is the question, or the variable in question. The amount of time that it takes for it to hit the ground is what we're trying to solve for. We have v naught, or v sub 0, appearing again, which is the initial velocity. If our object is being dropped, not thrown down, then the initial velocity is 0 in this case. If we were throwing it down with a certain amount of force or at a certain velocity, we'd have some other value there. But we're just starting it from a motionless point and dropping it. And the other piece of information that we have is h sub 0, or h naught. That is the initial height, which is the 190 feet that we are above the ground. So altogether, what we're trying to solve is 0 equals negative 16 times t squared, where t is still that unknown that we're trying to solve for, plus 0 times t, or we could just drop that term out since it's times 0, plus 190. We'll ask Symbolab to solve that equation. 0 equals negative 16t squared. We'll drop out that middle term since it's just 0, plus 190. And we end up with two values in this case. The negative value doesn't make sense. We can't have a negative amount of time. We're measuring time moving forward. So our answer would be about 3.4 seconds. So after about 3.4 seconds, this object would hit the ground after being dropped from that height of 190 feet.